Good morning, 8th grade, 7th grade APA, and 6th grade math classes. Good afternoon, good evening, whatever time it is that you're watching this video. I am continuing our notes on classifying real numbers. So in case you missed this in class, or you weren't here, or you don't have something completely done, this is the time to get it. So on this, this says homework 5, but again, this is notes. We're classifying the numbers in the table by checking all that apply. So I have -6 3/4. This is not a natural number because it's not a number that we normally or naturally count with. This is not a whole number because it has a decimal value. It's not an integer because it's not the opposite of a whole number. It will start off being a rational number. And all of these are real. So I'm going to go ahead and check off real for all of them because that applies to all of them. All right, then I have the square root of 175. So with my calculator, I would double check just to make sure that it's not a perfect square. Clear my calculator. So I would check and I would do the square root. So second square root 175 equals, that's 13.2287 yada yada yada. That is not a perfect square, so that number is irrational. 5 pi. Any number with pi is irrational. 30/3. Let's divide. 30 divided by 3 is 10. That is a number that I naturally count with, so it is natural. It is whole, because if it's natural, it's also whole, it's also an integer, it's also rational, and of course, it's also real. So I'm going to check off all of these except for irrational, because 10 is a rational number. Now this says the opposite of the square root of 9. If I'm not sure what that is, I'm going to go back to my calculator. And I'm going to say the opposite of the square root of 9. Okay? Then I'm going to hit enter, and that's going to be -3, or the opposite of 3. So I'm going to put that actually -3 here. I'm going to put 10 here. Okay, -3 is not a natural number because I do not naturally count with it. It is not a whole number because it has this negative sign, but it is an integer because it's the opposite of a whole number. Oops, should have put a check here, my bad. And it is a rational number. Okay? Number 6, Rachel states that -5.5 is an integer because it is negative. Is she correct? Why or why not? Integers are whole numbers and their opposites. -5.5 is not the opposite of a whole. Done. Jeremy says that 5.6766766777 is a rational number because it is a decimal that goes on forever with a pattern. Is he correct? Why or why not? Okay, this isn't necessarily a repeating pattern because this is 67, this is 6677, this is 666777, and it's going to keep going on and on and on like that forever, and that's not a repeating pattern. So this would be no. The pattern doesn't repeat. Therefore, it is irrational. All right, now at the bottom third of the paper, the graphic organizer represents the sets of all real numbers, which could be the value of D. So we need to go back and remember what these groups are as we labeled them. So E is a natural number. I'm going to stick natural in there. D is whole. I'm thinking W for whole. C is integers. D is rational. And A is irrational. All right, so which one could be a whole number? This is not a whole number. This is the whole number because remember I said that 0 is in the middle of the word whole. This is a fractional part and this has a decimal part as well. So B would be my best answer here. Which could not be the value of B? So going to B, that's a rational number. So the only thing I need to look out there for is an imperfect square because it says not. 5 is a rational number. 1/2 is a rational number. Negative 12.5 is a rational number. Therefore, this guy would have to be it. And I could check it by finding the square root of 32. So second square root 32 is 5.6585. Yep, that's the winner. Give an example of a value that could be represented by A. Well, there's one guy there. But remember, if we're talking about imperfect squares, we want the numbers that are not perfect squares. So the numbers that are perfect squares are 1, 4, 9, 16, 25, and so on. So I would choose a number in between 1 and 4, or in between 4 and 9, or in between 9 and 16, or in between 16 and 25, and so on. So I'm going to choose a number between 16 and 25, and let's say, 20. So the square root of 20, and then I'll check. So second square root, come on, radical 20, and that would work. All right, let's go on to the back. Rational versus irrational numbers. Complete the table below. 5 and 1/25. Is this rational or irrational? And explain. This is rational. It can be written as a fraction. It's got a fraction in it. It's a mixed number. All right, number 2, the square root of 126. Guess what I'm going to do? Check. Second square root 126. That is not a rational number. Irrational. Because it is an imperfect square. All right, so this is an imperfect square. This looks like it's infinite non-repeating decimal, so it's also irrational. There's no pattern here, no rhyme, no reason. Infinite or non-terminating, that's what infinite means. Non-repeating decimal. Negative 17 is an integer, so that's a rational number. It's the opposite of 17. And 0.777, hi, good morning, is a rational number. And it's an infinitely repeating decimal. All right, which of the following is an example of a rational number between 7 and 8? So between 7 and 8, between $7 and $8. Is this between 7 and 8? Yes, this is more than $7. This is more than $7 and less than 8. Gotta be specific. This is more than 7 and less than 8, more than 7 and less than 8, more than 7 and less than 8. So we would say all of the above. Which of the following is an example of an irrational number between 6 and 7? So I need something more than 6 and less than 7. And then I see a 2 pi in here, so I'm going to get my calculator. And I'm going to say 2 times, let me find the pi button, there it is, second pi, equals 6.28. That's more than 6 and less than 7. This is more than 6 and less than 7. Oh, but this is rational because it's a terminating decimal. This doesn't have any rhyme or reason, so this is irrational. and between 6 and 7, because that's what I'm looking for. So yes, yes, just and C here. B would not be it because this is a terminating decimal and I can write that as a fraction. Lastly, fill in the statements with either sometimes, always, or never in order to make it a true statement. The square roots of perfect squares will never be rational numbers because perfect squares is the key word here. Repeating decimals will blank be rational, and irrational numbers will blank be able to be written as fractions. All right, repeating decimals will always be rational numbers, and irrational numbers will never be able to be written as fractions. Okay? And that's it. Have a good one. Just kidding. I know some of y'all might want to know what app that is. It's called Calculate 84. And it basically makes your phone and takes your phone and turns it into a graphing calculator. And you can use this at home. It says use alongside TI-84, which we have the TI Inspire here. Okay, bye for real now.